Yeah. It is recording. Okay, good. Do I need to leave it over there? Maybe I do. Is this the next thing that you guys see on your paper? Yeah. Okay. Would you guys take a look, and we're going to state the power and the constant of variation for the function f of x equals the fourth root of x, and then we're going to graph it. Okay, so first of all, how can I write the fourth root of x as a power? Anybody know? X to the 1/4 power. All right, go ahead and put that up on your graphing calculator and tell me what you see. Anybody put that on yet? Tell me what it kind of looks like. It does kind of look like the square root function. Fourth root is actually growing at a slower rate, so the curve isn't even increasing as fast. Let's do some fourth roots. For instance, like it's the fourth root of 16. That just means what to the fourth power is 16. What would be the answer to that? What's the fourth root of 16? 4 to the fourth is 16? 2. 2 to the fourth is 16, right? Okay. Or, like, if I wanted to do the fourth root of 81, what's the fourth root of 81? What number to the fourth power? Okay. So if you were graphing points, that's how they would work. Fourth root. They're undoing the fourth power. So I'm going to state the power then is the 1/4 power, right? And the constant of variation is the number in front. What's in front? 1. Okay. So let's talk about a couple things, and we'll actually even go through things like domain and range. So you can put these on here. If I asked for the domain of this, what would you tell me? What's the domain of this? Similar to a square root, you can't take the fourth root of negative numbers because you can't have something raised to the fourth power. Like if I raised negative 2 to the fourth power, let's think about that. That would be negative 2 times negative 2. Now it's positive, right? Times negative 2, now it's negative. Now it's positive again. So if a fourth root is undoing the fourth power, it's not possible to have fourth root of negative numbers because no number raised to the fourth power would ever be negative. What does the range look like then? What is the range? What's the smallest thing I couldn't put in? 0. What's the fourth root of 0? 0. Okay. All right. Then we already talked about how the constant of variation is 1. That's up there in the problem. Hopefully you wrote that down. Power is 1/4. Constant of variation is 1. I could go through and ask all kinds of questions. Let's talk through them. This is bounded below. It really hits here. That means it's bounded below. What other things have I asked you questions about? Where is it increasing? increasing from 0 to infinity? Those are x values. Is it decreasing? No. Is there any symmetry, even or odd or neither? Neither. Okay, those are all things that we've talked about before. What else? Have I asked you questions about domain, range, even, odd? Ooh, I could ask you to do the inverse, couldn't I? If I flipped these around, I just was telling you what the inverse was in another way. What do you think it is? What's the inverse of the fourth root of x? What undoes the fourth root of x? Or what does it undo? X to the fourth would be the inverse. Because x to the fourth and x to the 1/4 would undo each other. Okay, before we move on, most of the power functions we're going to talk about today are integer powers. But I wanted to point this out because you might see something like this. This is actually a power function, but some of you might forget how to write that as a power function. This is not this example. How do we write this as a power of x? What kind of powers means they take the reciprocal? Yeah. I'm not asking you to solve it or do the. I'm not asking you to solve this. I'm saying what power is this the same as? I'm trying to rewrite it. If I asked you what power function this was, this is actually a power function. The power is -3. The constant of variation is also 1. Okay. Next, let's take a look at monomial functions. A monomial function is a type of power function. On the last one, do you remember how the power was 1/4? Okay. Monomial functions, it says this. Okay, so it's the last thing we graphed a monomial function. I'll tell you again, its power was 1/4, was the last thing we graphed a monomial function.
Yeah.
This has to be an integer. Was x to the 1/4 a monomial function? No, why not? 1/4 is not an integer. It is a type of power function, but be specific. When I talk about monomial functions, I'm talking about x to the first, x to the second, x to the third, x to the fourth. Does that make sense? Okay. So be careful that there's some little things here. Constant is just going to be a number in front. So things with an integer power and any number in front are called monomial functions. So, take a look at the next example. It says, describe how to obtain the graph of the function f of x equals 3x cubed from the graph of g of x equals x to the nth with the same power n. So let's sort through what that means. All I'm saying is, this is related to just the regular x to the nth same power. What's the power on that? 3. This is related to x to the third. Okay, why? Because, right, we call this the constant of variation, but let's think of it as transformation. How is it related to x to the third? Transformations from last chapter. How is 3x to the third related to x? It's just a vertical stretch. Vertical stretch of what? Of 3. See, there was nothing in front of this now, and now there is a 3.
So I'm going to say it's related to x to the third, and it is a vertical stretch of 3.
Without even taking a look at the graph on our graphing calculator, we should be able to draw a picture in the air, right? It's going to look like this. It's going to be a little narrower, okay?
But an x cubing graph should look like this, and this is just going to be a little bit narrower. Okay?
All right. If I asked you to analyze something like this, you should be able to do that. So you should be able to tell me that.
We'll go through it, so on your homework you know how to do this. The domain on this is what? Negative infinity to infinity. The range. Negative infinity to infinity. Is this continuous? I'm going to write, because some functions are not continuous and they have certain spots where they're not, so I'm going to write continuous, and I'm going to write this, negative infinity to infinity, and what that tells me is it's continuous on the entire graph.
Does this have any kind of symmetry? What? No? We have two types. Even was what kind? Symmetric to the y-axis?
That, right?
We had rotation symmetry, and so Kylie's saying that it's odd, right? So when we talk about symmetry, if I ask you about the symmetry, you can tell me it's odd or even, or you can tell me what type. So I'm going to say odd, and in parentheses, rotation symmetry. Okie dokie. Let's see. Is this increasing, decreasing? If so, where? Where is it increasing and decreasing? And it's increasing? And make sure we realize for increasing, decreasing, this is left to right. So negative infinity to infinity. Is this graph bounded? No. Does this graph have any asymptotes? No. Do you guys see how I'm coding in everything that we did last chapter? Hopefully. Okay. And then we should talk about end behavior, and this is going to be a work in progress, so this is something new. End behavior means what's the graph doing at the end? So I'm going to write this down. I want you to write it down, and we're going to practice it. Limit as x goes to infinity of f of x. Write it. Limit as x goes to infinity of f of x equals, and then limit as x goes to infinity. Oh, where's my eraser? It should be as x, the second one should be as x goes to negative infinity of f of x. Okay, so here's what this means. X going to infinity means on the graph, if I can do a different color, on the graph, as we're going to the right, what is the graph doing? What is f of x doing as I'm going to the right? It's going up, right? So what this means is as x goes to infinity, the graph is also going to infinity. So we fill that in with an infinity sign. That's a bad infinity